Hello, Algebra 2. Welcome back. And we are continuing on in our Unit 4. Here we're going to be talking about something you probably haven't seen before. It's called composite functions. We're taking the composition of a function. Okay. So in the last video, we talked about operations with functions, right? How we can, like if we have a f of x function or a g of x function, we can add those functions together or subtract or multiply or divide. Now in this one, we're going to be kind of making those functions kind of interact with one another, okay? We're going to be kind of plugging one into the other and vice versa, okay? So, but first, let's just review a little bit. Again, I know this notation is always confusing for kids, so it always helps to review, right? So if we have f of x equals 5x squared plus 2. Again, what this is saying is f is the name of this function and x is the variable used in the function. Okay, so it's kind of the f equation in terms of x. And then we have the second equation, that's the g function. Its name is g and it's in terms of x. So x is the variable and then you actually see two x's in that one. Okay, so if we do this one, this is saying f of 3. Okay, so instead of saying, okay, f of x, right? It's saying f of 3. So this means what this is saying is x is equal to 3. So we take that x, every x we see in this equation, we're going to replace with a 3. Okay, so instead of saying 5x squared plus 2, it's going to say 5 times 3 squared plus 2. Okay, so we replace the x with the 3 as that tells me to do. Okay, and now we just simplify this down. Okay, so this is saying 5 times 3 squared. Again, order of operations says instead of doing 5 times 3 first, I do 3 squared. 3 squared is 9, so that would be 5 times 9 plus 2. And then from there, I could do 5 times 9 is 45. And then 45 plus 2 is 47. Okay, so that would be my answer to this. So again, officially, I could say f of 3 equals 47. So that is the first one. Again, just the basics. Always good to review that first. Now, look at letter B, okay? How we would say this, I'll write over here how you would kind of say this, because it's kind of confusing. F of G of X. So this would be saying find F of G of X. Kind of weird, right? It's kind of, again, a function within a function type thing, okay? But mathematically, what I do with that is I'm going to take the g of x function, okay? So I just have this here, okay? F of g of x. So what this is telling me to do, right? Notice the x is still in the most inward parentheses, okay? So this means I'm not going to be substituting in a value like I did for this one. So it's saying keep it in terms of x. But what this is saying take the g of x function, take this whole thing, this whole group, okay? Take this whole group, and it's saying plug that in for every x that we see in the f equation. It's kind of weird. So again, that's every x that I see in the f equation. That's just one. I just have this 5x squared. So everywhere I see an x in this first equation, I'm going to take this whole group and I'm going to replace the x in there with that. Okay, again, pretty weird. But here's how it looks initially, okay? So again, I have my f equation, just my standard f equation, 5x squared plus 2. Okay, again, this x is going to be replaced with this whole group right here. So instead, it's going to be 5 times 7x squared minus x squared plus 2. Okay, so you see what I did there? I replaced the letter x with the group, the g of x group, that whole group. Okay, and so again, it can be kind of weird to get started with these, but that's what this is saying. Kind of take the composite function of f of g of x. Okay, take this whole group, plug it into f. Okay, and now that I did that, that's not it. Now I need to simplify this down. But what this is saying is, okay, first, again, order of operations says deal with the exponents first. So I need to square this group. And again, squaring a group means that I actually need to kind of expand this. Right? So this is saying take that group times itself, right? So that's what that's saying. And for this, I need to actually FOIL that, right? This is saying it's a binomial times a binomial. So I'm going to FOIL that to kind of condense this into one group, okay? So I'm going to do 7x squared times 7x squared, and that's a big number, right? So 7x squared times 7x squared is going to be 49x to the fourth, right? I'm adding those exponents together. So first outer, right? So 7x squared times negative 1x, okay? So it's going to be negative 7x to the third, right? That's had a 1 exponent on it. So 7x to the third, and then I do inner, right? First, outer, inner, last. So inner, negative 1x times 7x squared, the same as the last one I did. So that's another negative 7x to the third. And then negative x times negative x, my last term. So negative 1x times negative 1x gives me positive 1x squared. Okay. And again, that's just this group multiplied. Let me write this over here. And then I have a plus 2 from there, right? Like with FOIL, like what often happens, I have two like terms here in the middle that have the same exponent. So I can combine those. So I'll have 49x to the fourth. Negative 7 minus negative 7 gives me negative 14x to the third. And then plus that x squared at the end. And then that plus 2 there. Okay, I'm almost done. Last thing I'm going to have to do is distribute this 5. I'm going to multiply each of these terms in here by this outside 5. So 5 times 49 ends up equaling 245. And again, x to the fourth, right? Because I'm not multiplying by any additional x's. And then 5 times negative 14 gives me negative 70 x to the third. And then 5 times x squared, just lump them together, positive 5x squared. And then again, that plus 2 afterwards. Okay. And then from here, I would look at this group and I would say, okay, can I simplify this? Do I have any like terms to combine or anything? And I don't, right? I would need them to have the same exponent to be able to combine, so I don't have that. So I started you off with a little bit of a messy one here, but f of g of x equals all this. Again, and that just came from, that's my old one. It just came from substituting in my g group in for f and simplifying it down from there. Okay, it looks pretty messy, but that is a tougher one, like I said. So let me erase this. I'll rewrite my answer up there, and then we will do letter C. All right, now for letter C is telling me g of f of negative 4. Okay, now a couple differences between this one and the last one that we just did. The last one, again, it was saying f of g of x, so the g and the f were in different order, right? So you have to think about what that means here. And then look what also happens. This is being replaced, right? The x in the parentheses is being replaced with the negative 4. So when that happens, that's the first thing I want you to observe, okay? Kind of with composition of functions, we kind of work inside out, okay? So we look at the inwardmost parentheses first, okay? That's saying negative 4. So you know that, okay, in this problem, x is going to equal negative 4, okay? And so we're going to substitute negative 4 in for x, okay? So x is going to equal negative 4. And where am I going to put that? Well, I'm going to put that into the f equation. Again, I'm working inside out here, okay? I'm actually going to do two things. So what I'm doing is I'm going to take negative 4, plug it in to the f equation, okay? And then I'll get a single number as an answer there, just like I did for this. But then I'm going to take that answer and I'm going to plug it into the g equation, okay? So again, we're kind of finding the answer for f, and then we're taking that answer, plugging it into g. So again, work inside out. Okay, that's the key for these. Okay, so first, again, I need to first evaluate f of negative 4. Okay, f of negative 4. So that's taking this equation, 5x squared plus 2, but again, it's replacing that x with a negative 4. Okay, and this isn't going to be as long as the last one, I promise. So again, for this one, I'm going to simplify this down. So negative 4 squared is going to be a positive 16. So 5 times 16 plus 2. Okay. And so then I would do 5 times 16 is going to be 80. 80 plus 2 equals 82. Okay. So that would be, so we could say f of negative 4 equals 82. Okay. So that would be just this, okay? I found f of negative 4. I found that when I plug negative 4 into the f equation, I get 82 as an answer, okay? But what it's telling me to do kind of in all of this is, okay, find that f of negative 4 answer, but then it's saying, okay, as the last step, take that answer and plug it in for g. Okay, so now that I found f of negative 4 equals 82, it's saying take that 82 and plug it into the g equation. Okay, and we're going to replace all the x's in that equation with 82. Okay, so for this one, I'm plugging in 82 into the g equation now. Okay, my f answer, I'm plugging that in for g. Okay, so 7x squared minus x. So all the x's are being replaced with 82s. So 7 times 82 squared minus 82. Okay, again, replacing all these x's. So I would do 82 squared. I can't do that off the top of my head, so let me get my thing here. So I would end up getting 82 squared. 82 squared is 6,274. Had to use my calculator for that one. Okay, so I have 7 times 6,274 minus 82. Okay, and now I need to do 7 times this big 6,000 number. So then from here, I would do 7 times 6,274, and I would get 47,068. And then I would do that big number minus 82, and I would get 46,986. Big numbers here, okay? And don't worry, I had to use a calculator for that. So my final answer. So I found that g of f of negative 4 equals 46,986, okay? So that's the basics of composite functions, okay? Let's just start with a fresh example, do a few more, and we'll be all set, okay? And this one's a little bit simpler, not as messy of expressions here for f and g, okay? So looking at letter A here, f of g of negative 3, again, working inside out. So what do we see? We see that, okay, negative 3. So initially, we're going to replace negative 3 for x, okay, and we're going to do that into the g equation, okay. And look at the g equation, nice and simple for you here, okay. So g of negative 3 would equal 6 times negative 3, right? Just replacing the x with the negative 3. And so I could say g of negative 3 equals negative 18. But again, it's taking that g of negative 3, that answer, and plugging it into the f equation. Okay, so it's taking that, right? And it's saying, okay, f of g of negative 3 would equal 2 times, not negative 3, but again, the x's are being replaced with this answer. So negative 18. So 2 times negative 18 squared minus 3. Okay, so I would do that 2 times negative 18 squared. So negative 18 squared is 324 minus 3, right? And then so 2 times 324 would give me 648. And then 648 minus 3 would give me 645. Okay, so that's my final answer. F of g of negative 3 equals 645. So again, that's just a little bit of a quicker example here. Take negative 3, plug it in for x in the g equation, then take that answer, plug it in for f, inside out. Letter B, g of f of x. So again, here we observe first, is x replaced with a number? No, okay, so we're gonna skip kind of that step 1 here, okay? And again, when this happens, we don't plug anything in for x, but what this is saying is g of f of x. So it's saying like take the f of x whole group, right? Because I didn't get that down to a single number, I just have that group. So take that whole group, plug it into the g equation, but replace all the x's in the g equation with this whole group, okay? So here's how that's going to look, g of f of x. So this is going to be, again, I take my g equation, that's kind of my skeleton here, my structure. So it's super simple too, right? 6 times x. But instead of being 6 times x, it's going to be 6 times the f group, right? The f group, which is 2x squared minus 3. Again, taking that and just replacing the x with the whole group, okay? And then I would just simplify from here, right? And this is easier to simplify. So I distribute that. 6 times 2x squared would give me 12x squared, and then 6 times negative 3 would end up giving me negative 18. And then I can't reduce that at all either, okay? So I would say, kind of as my final answer, g of f of x equals this group right here, 12x squared minus 18, okay? Again, it's okay to leave your answer as a group when it doesn't tell you to replace x with a number, right? Because we're still keeping the thing in terms of x. It's just kind of filling in a group for the x there, okay? Now, letter C, okay, a couple things different. It looks like this says fog of A, and that's what I like to call it in class too, fog of A. But this is another kind of, like, it's telling you to do a composite function here. It's telling you to do the same thing, okay, but it's just writing it in a different way. What this is the same as is f of g of A, okay. So it's basically the same as the ones we did before, just written in a different way. So the same idea, you kind of go like inside out, except you don't have like the parentheses there to help you. So if, like, what I tell my kids to do too sometimes is, like, you could draw your parenthesis around your second letter there, right after the O, to remind you of what to do. But again, this is just another notation of composite. Okay, so then what does that mean? Again, we look what's in the inwardmost parentheses first, okay, and we see it's an A. Again, that's not my original variable. And this is weird too. Sometimes you'll see this, like, this doesn't seem like you're doing much, but this is saying, okay, we're kind of putting my equation in terms of a new variable. Instead of x, we're going to use a. And again, it doesn't seem like super productive to do this, but like it's what it's asking us to do, okay? So it's saying take the g equation and replace all the x's with a's, okay? So this is going to be like very easy. So g of a, right? What's my g equation? My g equation is 6 times x. But again, we're going to take every time I see an x, I'm going to replace it with an a. Again, so it's just very simple, 6 times a. So not like super difficult or anything, but it's just replacing the x with an a. And again, you'll see this sometimes, so I just wanted to show you one like that. But again, what do we do with that? Again, kind of thinking this inside out. I take that g of a group, or this just single term, 6 times a, and I replace all the x's in the f group with that, okay? So f of g of a, again, that's what this fog of a means, right? It's saying, okay, take that group 6a, put it in for all the x's in here, okay? So instead of 2 times x squared minus 3, it's going to be 2 times 6a squared minus 3. Okay, so I replaced all my x's with the g of a answer, okay? And then from here, I just simplify it down. So I would do 6a squared. Again, this is a single term, so I can kind of like distribute that exponent, okay? You can't do that when it's like multiple terms like this. You can't distribute the exponent. You have to expand it in terms of like groups. But when it's a single term, you can do this, okay? So it's going to be 2 times, so 6 squared is going to be 36, and then a squared, I can just write that, a squared. So 6a squared is 36a squared, like that. And then minus 3. And then lastly, I would do 2 times 36a squared to give me 72a squared. And then that minus 3 just comes after. And I can't combine those, right? They're not like terms. Okay, so this would be my final answer right here. 72a squared minus 3 would be f of g of a. So now lastly here for letter D, okay, I have g of f of 7. And again, they give you this other notation. It helps to rewrite it first to do with whichever one you're more comfortable with. So I like the other one because I like that inside out rule. Helps me to do this stuff. So g of f of 7. This letter D is equivalent to that. Okay. So again, working inside out, what do we see? Again, we see, okay, there's a 7 in the parentheses instead of an x. So I'm going to plug in 7 for x. Okay. Which equation am I going to plug it into? I'm going to plug it into the f equation, right? So I'm going to take that f equation, right? I'm going to find f of 7 first. I'm going to find an answer for that. So instead, it's going to be 2 times 7 squared minus 3, okay? And then I would work it down from there, right? So 7 squared is 49. So 2 times 49 would be 98. And then 98 minus 3 would be 95. 95. Okay. So I just found f of 7, right? F of 7 is 95. Okay. Now, but it's saying, okay, one more step in the inside out. G of f of 7 means I take that f of 7 answer, which is 95, and I plug that in to G, right? So G is a very simple equation. Okay. So G of f of 7 would be saying 6 times 95, okay? And 6 times 95 ends up giving me 570, I believe. Let me check on that. Yes, my mental math was correct. I got that one. So, okay, so G of f of 7 is 570. You just do 6 times the f answer there. Okay? So it's a super weird topic. It's weird to explain to, but I hope it makes sense. I hope you'd be able to do these on your own now. So, thank you for following. Good job.